This is Unit 8, Lesson 12, Math Unmasked. Okay, and today in class we talked about two ideas, mad and mean, and they are relation. The mean is another word for average, and we know that this is a hypothetical fair share. Sometimes we talk about it as the balancing point. It's usually in the middle of a set of data. So I've got this graph here about cookies per day, and we've got two people that have 0 cookies, two people that have one person who ate 2, 3 people who ate 3, and one person who ate 5. That's probably me. So we know that we find the mean or average by first adding all the values and then dividing by the number of values we had. So in this case, to find this, we would have to take 0 plus 0 plus 1 plus 1 plus 2 plus 3 plus 3 plus 3 plus 5. So if I add this all up, 1, 2, 4, 7, 10, 13, 18, and then there were 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers that we did. So 18 divided by 9 is 2. So our average right here is 2. Sometimes we mark those with triangles on our graph, and you can see it is kind of in the middle, a little bit closer to the center because there's more points clustered here. 5 is kind of an outlier. Now, mad is what's known as the mean absolute derivation. But my class likes to think about it more as the mean average distance. Because what this does is it averages the averages. It says, okay, this 0 here, how far is this away from the average? So that's 2 jumps away from the average. That one is 2. This 1 is 1 away from the average. 1 away from the average. This is 0 away from the mean because it is the mean. These 3s are all 1 jump away from that average. And the 5 here is 1, 2, 3 jumps away from that average. Now, if I take all of these and then my steps are the same, I add all of those values, I add all of the distances, and then I will average them together. So 2, 4, 5, 6, 7, 8, 9, 12. And then there are still 9 values, right? So this time it's not going to work out quite as easily as it did before, right? I'm going to have 1 and 3/9 or 1 and a third, or if I wrote this as a decimal, it would be 1.3 repeating. And that is our mad. So it is saying, okay, we've got that. So what does this mean? Well, we know that the mean is usually found in the middle of our data set. It's one of our measures of center. If I have a relatively small mad, this is about 1. That means all of my dots are pretty close together. On average, all of my dots are a little over 1 jump away from the average. And that's true, right? This is my farthest, and that's really an outlier. Okay. If I have a really large mad, like let's say 10 or 14, that would mean that on average, my dots are 10 or 14 jumps away from that triangle, from that average. So it means my data has much more variability. It's much more spread out. Okay. So today on our homework, we are asking you to talk about those things. Which one has a higher mad, a lower mad, things like that. What does a smaller mean, a larger mean in these contexts? So this gives you an idea of what you need to. If you are still confused, Khan Academy, Mr. Morgan's Math Help are other places that you can go. Good luck on your homework.